Science,
engineering,
medicine,
chemistry,
physics,
biology, humanities, cardiology,
computer, public health, global
aeronautics, science communication.
Hello everyone, I'm Gareth Mitchell, and today encouraging results from the latest research into the active compound in magic mushrooms. Also, the PhD student who's just won a big innovation award for some AI that was inspired by a family tragedy. And Sky at Night presenter Maggie Aderin-Pocock remembers being daunted when she first took on the programme.
Patrick Moore, my predecessor on Sky at Night, he was the longest serving television presenter. So he's presented the same programme for 57 years. So I must admit, when I stepped into his shoes, I think I was a rabbit in the headlights, but it was a wonderful opportunity.
The Imperial College Podcast.
Well, as usual, we are going to jump through a couple of the news stories that have been coming out of Imperial College in recent days and weeks. And Hayley Dunning is here. Hayley, let's talk about small islands and sometimes big and sometimes small animals. Unpick this one for us.
Yeah, this is an interesting story about evolution on islands. So biologists have observed that sometimes you seem to get these strange things on islands where animals that are big on the mainland get small when they're on islands. So, for example, about 10,000 years ago, a lot of the Mediterranean islands had small animals on them, like pygmy hippos or dwarf elephants. But then some animals that are usually small on the continent get much bigger on islands. So, for example, we can think of Komodo dragons, really big lizards, and actually dodos are really big pigeons. And so these have been observed, but they haven't really known if it's a rule. So now researchers have done a big sort of meta-analysis and looked at lots of studies and lots of species. They looked at over 1,000 species of land animals and seen that it does seem to be a rule.
And what are they drawing out of this then, apart from being obviously very relieved that there does seem to be a rule? But what does this mean, I suppose, is the blunt question.
Yeah, well, now they can kind of see what also shapes these evolutions. So, so for example, the animals that are big and get smaller, that's probably due to limited resources in space. But then the animals that are small and get bigger, they have lower competition, so there's less other animals like them, and also fewer predators, so they're able to release the constraints on their body size. Those are the theories of why that might happen, but there's also the controls on how extreme that might be. So, for example, on smaller, more remote islands, the effects will be more pronounced. And also climate and seasonality will play a role in the evolution as well.
Fascinating stuff. Hayley, thank you so much for that. Now, Caroline Brogan is also here. So we're now going to go to Antarctica, from small islands to Antarctica, to discuss, asteroids. Tell me more.
Yeah, so one of the issues with identifying asteroid impacts that happened hundreds of thousands of years ago is that they kind of vaporize into very small particles, and that makes it difficult to detect. But researchers from the University of Kent and Imperial have now discovered extraterrestrial particles in Antarctica, which they say is evidence of an asteroid impact 430,000 years ago.
And what are they saying about this discovery, about this impact?
They say the asteroid was at least 100 metres in diameter and that it hit the ice sheet at a really high speed. This impact unleashed a jet of vaporised material which scattered and settled over the Antarctic ice sheet. One of the study authors, Matt Genge, in Imperial's Department of Earth Science and Engineering, said, "Although we can be pretty sure our ancestors didn't witness the explosion, it would surely have scared a lot of penguins."
That's the best quote I've heard all week already. That's just made my day hearing that, Caroline. So the way you've described this is, and the scientists have described it, is that you've got all this dust. It's all going on 430,000 years ago. So how have they managed to say anything about it so far on from all these little particles?
Well, they found these tiny particles which were about 100 micrometers in width. But Dr. Genge said, the smoking gun is in the dust. They looked at the presence of oxygen in the particles, and that tells us about the intense heat generated by what was essentially an explosion. The explosion was enough to turn frigid ice into superheated steam, for example, which leaves an oxygen trace. He also goes on to say that it's astonishing that such a tremendous event could leave almost no trace at all, and that they could literally only be seen through a microscope in the tiny dust particles that they produce.
All right, well, we'll leave it there. Thank you so much. That's Caroline Brogan, and we also heard there from Hayley Dunning. Well, now, happy birthday, Centre for Psychedelic Research, currently celebrating its second anniversary amid something of a psychedelic renaissance. Researchers at the centre have been in the headlines in recent days, publishing results of the most rigorous trial to date, assessing the therapeutic potential of the active compound in magic mushrooms. Ryan O'Hare has been speaking to Dr. Robin Carhart-Harris, the head of the centre, about what's in the pipeline and the future of psychedelics. First, though, looking back over a busy 2 years, how have things gone?
Well, they've gone remarkably well, I'm pleased to say. We've completed a major clinical trial comparing psilocybin with a established antidepressant drug. We've also completed a healthy volunteer study where people are given psilocybin for the first time, and we look at brain waves, and we look in their brains before and 1 month after using magnetic resonance imaging. We've got some really exciting results on that. We're writing that up. And those are just 2 studies. We've got others planned, one with psilocybin in anorexia, one with psilocybin in chronic pain. We continue to do consciousness research, brain imaging research with compounds like DMT, found in so-called ayahuasca. We also plan to do work with 5-methoxy-DMT, brain imaging work there. So a rich portfolio, and we've been very productive despite the obvious things going on in the world. So we've been, among the lucky ones.
So in talking about the work that you've got ongoing at the moment, you mentioned the psilocybin trials using brain imaging to see what's actually going on inside the brain. Can you give us any sort of tantalising insights into what we might expect from that work?
Well, if we think about our depression research, we do look in the brain before and after psilocybin, and then the comparator, which is called escitalopram. It's a Prozac-like antidepressant. And we see quite different effects on brain function. So if you show people emotionally charged faces, people with, looking really happy or really angry or frowny, then the brain's responsiveness to those emotions is dampened under the antidepressant. Now, with the psilocybin, we didn't see that. We saw a slight dampening of the brain's response to very negative emotions, but the positive emotions, the happy faces, they weren't affected. So on balance, you see with the Prozac-like antidepressant, the established antidepressant that you take every day, we see a sort of dampening, a muffling of the brain's responsiveness to emotional stimuli relative to the psilocybin. And that makes sense because the psilocybin is more like an emotional recalibration or reset, whereas the SSRI is more like taking the edge off emotional intensity, which helps with like stress management.
There's been somewhat of a psychedelic renaissance. So do you think these compounds are sort of gaining more traction in terms of therapeutics or potential therapeutic benefits?
They are gaining traction. I mean, we can see that in terms of regulators granting breakthrough therapy designation, so helping along in a sense, or at least unhindering the medical development of psychedelics into potential licensed medicines. And that could happen with MDMA therapy for post-traumatic stress disorder, maybe within 2 years. And then you see other things happening, like the state of Oregon in the US approving legal psilocybin therapy. Process of a couple of years will happen for that to roll out such that people can actually access that legal psilocybin therapy, magic mushroom therapy. But these are real changes, and companies in this space are now, listed on the NASDAQ and valued at close to $2 billion, I think, one company. And so major things are happening in this space. Yeah, so the mainstreaming is here in a way. It's just starting. So it's a fascinating thing to watch, yeah.
With all this in mind, what's the future looking like for psychedelics and psychedelic therapy in the UK and around the world?
Yeah, well, it's looking very bright, and I think the optimistic take is to say that for so long people have lamented that mental health treatments aren't good enough. They're too expensive if it's psychotherapy. They're too hard to access if it's psychotherapy. They don't work well enough if they're drugs, and they have side effects. And we need a solution. We need a breakthrough. And they've lacked hope, really, because we haven't had a breakthrough for a long time. And now I think that psychedelic therapy gives cause for hope. I do feel we can feel optimistic about the potential to treat mental illness and improve mental health. And that's a wonderful thing. And that's coming, I believe, because of advances in psychedelic therapy and psychedelic medicine. That's the optimistic take, and the cautious one is that this is a combination treatment, and I really must emphasize that. I always do. We're talking about psychedelic therapy. This isn't, I just need to get a batch of LSD or a handful of magic mushrooms and gobble them down and I'm going to cure my depression. It's really not that. And bad things can happen if people have that misconception of what we're doing here. So combination treatment means there's at least two components. There's more than one component. And the psychotherapy, the psychological support that's overlaid onto the drug experience itself is so essentially important to get these positive outcomes that we're seeing in our research.
Robin Carhart-Harris speaking there to Ryan O'Hare. Well, now how a family tragedy led to an award of £10,000. Final year Imperial PhD student Sam Turka has recently won the Institute of Global Health Innovation's Student Challenges competition for his healthcare innovation, Third Eye Intelligence. It's an AI-driven platform that predicts a patient's risk of organ failure. Sam's been telling Hayley Dunning how the loss of his grandfather inspired him to develop the technology.
My grandfather was admitted to intensive care, and within a short time frame of about 5 days, he died due to multi-organ failure. And the big question that led to that is, how does a person come to the highest echelon of care and still not survive? And digging around a little bit, I found out that it's not him alone. It's actually a problem that exists globally. And there are about 85 million patients that are also admitted to intensive care, yet only up to 50% of them survive. Why does that happen is what drew me towards exploring this.
Sounds like it must be a very complex issue if it's global and ongoing. So what are the things specifically that make it so difficult to tackle?
From a clinician's perspective, I think there's multiple factors. Number one is that they have to absorb and understand this huge corpus of information for every single patient that's coming in. And it's a lot of information to juggle that is also updating in real time. In reality, it's just the case that these organ failures are detected often too late. So interventions are delayed and therefore survival chances are lower.
Your approach then is to try and help understand all this information earlier on by using AI. So how does that work?
We essentially created an early warning system for organ failure. What our AI does is essentially process and amalgamate all this data that is currently stored in electronic health records. This is a huge multimodal data comprising of text, images, live vitals, etc. All of this gets processed and it predicts the risk of organ failure before onset. So that longer time window to administer those life-saving interventions can be done before it's too late.
What makes your AI different? Has anyone else tried this before?
Usually most AI models are hand-designed and in sequential manners. But the problem is they only work on one particular type of data modality. And combining it for multiple data to do multitasking is actually a very difficult question that is still an open research area. So the way we approached it was the evolving AI model. So we said, instead of us designing our AI, what if we task another AI to design our AI models for us? So instead of training an AI model to directly give you an output, you're really questioning what is the essence of learning so that you can improve the model's generalizability to different problems.
I know that you have actually tested it on a big patient data set. So how did it work?
We were able to predict organ failure for 4 different types: heart-based conditions, lungs, and kidney. And the septic shock onset up to 48 hours in advance with an accuracy of 91%. But if you change the time window, then you get a different accuracy. For example, if you go 28 hours instead of 48 hours, the accuracy increases to about 96%.
Ultimately, what do you hope this innovation will achieve, and how could it impact real patients' lives in the ICU?
The idea is on three fronts, which is automatically triage patients so you can actually manage ICU resources. But secondly, also to prevent unnecessary readmission into ICU, because being in ICU alone can be actually very detrimental. The third is actually preventing organ failure from happening in the first place, because then the care associated is also significantly easier on that front. And lastly, reduce that length of stay in the ICU. With regards to the bigger picture, what we realize is since our model is learning a representation of how that patient is performing in a program, so mathematically, what we strongly believe is that we can actually simulate a patient. So what we want to create as a company is a patient simulation at the end of it. So all these other medical innovations that we have, such as drug development using AI, that trial process, treatment justification, clinical decision-making, all of this can be expedited because you have this simulation to test on. So if you think of it as an analogy to how we design cars, right? So we have this software called CAD, computer-aided design. So before you even make or manufacture a car, you first test it on computer simulations to ensure that it actually works as designed and intended to. And that expedites the process and reduces that failure cases during the manufacturing process. Similarly, we want to essentially create CADs for patients.
Sam Turka speaking there to Hayley Dunning. Well, finally, meet Dr. Maggie Aderin-Pocock, presenter of The Sky at Night and Stargazing on CBeebies. As a physicist and one of the UK's leading space scientists, she's worked on the spectrograph for the Gemini Observatory in Chile and satellites for climate change observations. Maggie was also one of the inaugural awardees of Suffrage Science, the Women in Science Awards scheme run by MRC London Institute of Medical Sciences, which now has a podcast. And we've decided to bring you an excerpt. Here, Maggie Aderin-Pocock tells broadcaster and writer Kat Arney about the challenges that she faced at school.
I have dyslexia. And of course, when you first go to school, it's all about reading and writing. So I went to school and I was put in the remedial class. And growing up in sort of a Nigerian family, my father always brought me up, education is so important, Before I went to school, my father was saying, so what college of Oxford are you going to go to? So he set the bar pretty high. And so going into school, I felt like a total failure because I wasn't progressing. Effectively put in the back of the class with the safety scissors and the glue. So it just didn't add up. But I was lucky that I was one day sitting in a science class and the teacher asked a question and I put my hand up and I was the only one with my hand up and the only one that got the question right. And it's funny, moments like that really just sort of give you confidence because you think, okay, maybe I'm not bad at everything. Maybe there is a role for me here. And so through that, I started to sort of engage a little more.
So you went on to do physics and mechanical engineering and work at Imperial. So tell me a bit about that time of your life, sort of getting into research and establishing yourself as a scientist in this, I'm going to say it, probably quite male-dominated field.
Yes. And it was, so I remember I used to love Imperial College, which is where I studied, because as a child I used to go to the Science Museum and I used to go into sort of the hall of rockets and stuff like that. So, oh my goodness. And then I'd look next door and that's where the clever people go. Wouldn't it be wonderful to go somewhere like that? And so when I got accepted into Imperial, I was so excited. But the cohort for the first year in physics was of the order of about 200 people. But I think of that 200, only 5 of us were girls. So it was sort of, definitely started off male dominated. And I think only 2 of us were black. But it's funny, although I might be sort of the only one of a kind, so only black woman in this cohort, I don't think it worried me. I wanted to study the science. And I think that's the power of having a crazy goal in mind.
My sister did physics at Imperial, and there was always that joke, if you were a woman among all these men, it's like the odds are good, but the goods are odd.
That's a lovely one. And it's funny because I met my husband at Imperial.
Well, it can't be that odd then.
Yes, because I think when I was there, the ratio was 8-1 men to women. That's before they got the medical school. So yes,
definitely. And then you've gone from being a researcher to now moving more towards doing media work and being a broadcaster, and incredibly, being a presenter on The Sky at Night, which is just one of the flagship science programs, certainly flagship space program. So how did you get there, and how did you kind of take on that mantle?
Yes, it was a sort of a long sort of process. I was working with some people at UCL, and one day someone suggested that I do a news programme. She couldn't make it. She'd been invited onto a news programme, and she asked me if I'd like to go instead. I was like, oh yeah, sure, why not? Yeah, great. That's where my first television appearances started. And then it sort of escalated from there. And Patrick Moore, my predecessor on Sky at Night, he was the longest serving television presenter. So he's presented the same programme for 57 years. So I must admit, when I stepped into his shoes, I think I was a rabbit in the headlights, but it was a wonderful opportunity.
I guess in many places in your career, you've been sort of the first woman, first black person, particularly first black woman, to be in some of the positions that you've had. And talking to many of the other women through the podcast, it's like sometimes you feel like you are the only woman in the room, and it would just be nice if there were a couple more people here and we could have, we could just change the norms of what this is like. So are there times in your career where you've really felt like I am just the only person like this here, and it's caused sort of friction or problems?
There's been a few examples where I've sort of turned up somewhere and it's the stereotype. They've seen a black woman. I remember going up to one of my contractors' offices, and I turned up at the security gate, and the guy sort of gave me I wasn't long out of university, and I was sort of wearing a suit and carrying a briefcase and feeling sort of quite
fancy.
Yes, quite grown up now. And he said, "Here are the keys, love. You need to start cleaning the offices at the back," because he saw a black woman and he assumed, point blank, a black woman must be here to clean. Now, there's nothing wrong with being a cleaner, but it's the assumption. And so that's the challenge, is taking on that stereotype, sort of trying to break those barriers.
And finally, your passion has always been space and going into space. Do you reckon you're going to get up there?
It has been the crazy dream of my life. One of my crazy ideas is to retire to Mars. So yeah, when I'm 80 and a bit doddery, there's less gravity on Mars. So, and think of the experiments you could do when you have a whole planet to explore. So yeah, it's a bit of a retirement plan now, but I'm still optimistic. I can't help it.
Maggie Aderin-Pocock speaking there to Kat Arney, and the full version of that episode is available on the Suffrage Science podcast. Just search for it on your favourite podcatcher. And there you will also find interviews with former Chief Medical Officer Dame Sally Davis and computing legend Professor Dame Wendy Hall. So do check it out. We thoroughly recommend it. And as for this podcast, that's it for this edition. But of course, as ever, we'll be back with more next month. So do join us then. In the meantime, from me, Gareth Mitchell, and all of us here on the podcast team, thanks for listening and goodbye.